The boat problem actually comes in several different flavors. I gave you guys one of them. And let me go ahead and just, the one I gave you is not, any harder or easier. It's just different. So in this particular question, what we need to figure out is how fast is the boat actually traveling across the river? So we set up the problem understanding that the boat is already perpendicular to the dock, so that if it travels directly across the river, it will be able to meet up with the dock. Just so you know, that makes the problem much easier than it could be. I want to be very clear about it. Had the dock been over here, and I asked you what angle would the boat have to go to make it to the dock, that is a really hard question. The math suddenly shoots up to something that's very extreme. It doesn't seem like it should be that hard, but it really is. By making it go straight across the river, we implicitly build in the possibility of a right triangle. Now, the boat's not going to face the dock and go straight across the river. In order for the boat to go across the river in a straight line, the boat has to turn itself into the current. The idea being that the boat can go at a speed that's faster than the current is going. So if the boat faces this direction, the current might push it back on track. Now, if you don't turn enough, the boat's progress still won't be right. You have to choose an angle so that the boat can successfully be pushed back onto track. The boat can travel at 8 meters per second, and the current is pushing you that direction at 5 meters per second. So I've arranged a bit of a triangle here to help me deal with the angles necessary to get my boat there. I didn't draw it to scale, although if you had drawn it to scale, you could easily measure the answer with a protractor. And this length right here would be the actual velocity of the boat across the river. It would be the resultant. Now, in order for me to be consistent, what I would really like to do is show you guys that you can use the same set of steps I gave in class. Although there is a clear shortcut on how you could solve this problem. I mean, just the way it's drawn, it should be clear that that's a right angle. The 8 has become the hypotenuse, and you could use just the Pythagorean theorem to figure out what the velocity is. So I do understand there's a shortcut here. However, I want to neglect that shortcut and show you that you could solve the problem using the same process that we had. And I think this is nice and deliberate. This angle's theta, which means that we don't actually know the direction of the boat, but we do know that it's going to have two components to its velocity, the blue arrows. There's I'll call this the y component of its velocity, which is going to be 8 cosine theta. And then there's this x component of its velocity, which is going to be negative 8 sine theta. Any question about where I got that from? All right. So there's the boat. There's the river. And then there's the result. If I line them up with X and Y, the boat there. If I line them up with X and Y, the boat has in the X direction negative 8 sine theta, and in the Y direction 8 cosine theta. The river is going to have, well, positive 5 and 0. And I can put my little X hats and Y hats here. And in the end, these have to add up so that there is no X component. Right? I want the boat to go strictly across the river. So I need the sum in the X direction for the result to be 0 in the X direction plus, well, whatever's left, 8 cosine theta in the Y direction. Now, this doesn't give me my answer directly, but it does give me a pathway to get the answer. It tells me that negative 8 sine theta plus 5 has to equal 0, which tells me that sine theta has to equal 5/8. Now that gets me theta, which I only need transient like to use right here to figure out how fast I'm going across the river. Do you guys know what to do here? What's the angle? Somebody give me the angle real quick.
38.7 degrees.
Excellent. So my y velocity then has to be 8 cosine 38.7 degrees. Which gives me what, like 6 point something? 6 point what? 6.24 meters per second. So that's how fast I'm actually going across the river, is 6.24 meters per second. Still not the answer, but at least I can use this to get the answer. So I need to turn my boat 38.7 degrees into the current of the river so I can go across the river. And now I need to know how long it's going to take me to go across the river. Well, it's a 200-meter river. I'm traveling at 6.24 meters per second. I'm pretty sure some division will give me the number of seconds it's going to take to get across the river. And I think it's like 32. Now, I completely get that you didn't have to do any of this work. I understand that. And so you could have just looked at the right triangle there, figured out what that side has to be, and you could have probably jumped right to the answer a lot faster. In fact, you could have done this without finding the angle at all, right? You could have done 5 squared plus vy squared equals 8 squared. You could have just used Pythagorean theorem. That would have given you the velocity in the y direction. And from there, you could have figured out how long it takes to get across the river. But the only reason that you can do that is because I made it so you can go directly across the river. If I'd put the dock anywhere else, your only hope would have been something like that. But in all honesty, these are just math problems. They're not really physics problems. I want you to be able to solve them, sure. I want you to be able to do the kind of resultants we're doing here. But we're just supposed to be practicing with vectors. That's all this is.